we are going to build artificial intelligence. I'm building an AI agent that will use the Udacity car simulator to complete a track. I want the agent to be able to drive the car in autonomous mode to complete the track. This Udacity simulator basically has a training mode, an autonomous mode, and it has a few different tracks that you can drive on. And what I'm going to do is program an artificial network to determine the speed and the throttle at a particular frame, and send that signal to the Udacity simulator and control this vehicle. The goal is to get the car to finish the track. I also am going to need to add some functionality to the Udacity simulator so that I can have a reset button, because ultimately I want the car to finish the track, and I've found that the car just sometimes gets stuck even when I do it in manual mode. So I want the car to be able to reset and start from the beginning if it gets stuck. And that's what I'm going to be doing today. All right, here's the model that I'm going to be working with. I'm taking out I'm using ResNet 50. I'm taking out the fully connected layer, adding in my own layer, and I want two output features, the throttle and the steering angle. I'm working with this little tutorial here I just want things to work as I expect them to work. I need to modify my training data a little bit and work on this data set class from PyTorch. I'm using PyTorch for this. When you run the Udacity simulator in training mode, it's going to collect all this data. You have a image for center, left, and right. Then you have a bunch of data over here too. This is like the speed. I don't remember the order of these, but it's like speed, throttle, brake, steering angle. So what I'm going to do right now is just take out the data that I need. I really only need the center image, throttle, and the steering angle. Most of this work right now is just me banging my head against the wall, trying to get pandas to work the way that I want it to work, and also just structuring my data, getting my data in the right format. I'm using this pre-built model, ResNet 50, and really all I need is just the data in the right structure so that I can feed it into the model and get out my output. So most of the work, is just structuring the data, wrangling the data, getting it in the right place. And also, this isn't even all of the training data that I'm working with. This is just a small subset of the data. But if it works on a small subset, then I can start to build a pipeline for getting more training data, feeding it through this pipeline, preparing it, and feeding it into the model. Booyah. All right, it looks like the model is working. So next step will be to train this thing. All right, let's talk about the Udacity car simulator a little bit. So here it is. This is built in Unity. It was kind of a pain to get this set up on my Linux machine, but finally it's working. I have this thing working, and also I have the ability to modify the code. I've kind of gone into the code a little bit and just tested it out to make sure that I could actually see the changes that I make in the code, and that's going to be important for one particular thing that I want to do. I want to add something to the Udacity simulator. I don't know C#, and this is built in C#, but I've learned enough to be able to do what I need to do. So there are two basic modes here. There's a training mode and an autonomous mode. I showed you some of the data before that's coming out of the training mode, and that is just simply collected by going here. Look, I can control this, and up in the upper left-hand corner, there's the steering angle. Down here, there's the miles per hour. And what this is going to do, see, look, this shit's stuck already. So what I need to do here when this thing gets stuck, I can't even get out of this. So my AI system's not gonna be able to get out of it if it makes a mistake. And I want to be able to just launch this thing and have it complete the course. If it makes a mistake, what it needs to do is it needs to escape, and it needs to go back to the same track that it was on. It's going to be an autonomous mode, of course, but this is the concept. There's no functionality for it to do that right now, so there are a few options. Like I could maybe program Python to like figure out where the training mode, but that's so messy. That's not worth it to do. So I'm just modifying the code to make it so that from this screen, if you press 0, it's going to go to the lake map down here. If you press 1, it's going to go to the mountain map. That's all I need to add to this. Took me a little while to just read through the code and understand that, but that's what I'm doing. So now if we go, let's go back to the training mode. And from here, I could press record, and it's going to start capturing the data. And the way that it does it is not like live. It's not like streaming the data to the files. It will actually, like, once you're done, you press record again, then it like replays everything, and it takes the data and puts it to the file. Now the thing that we are going to want to do is we want to run this thing in autonomous mode, and let me show you an example of a model. This was a model that I found online. It doesn't seem to be that great. It's not really working that great, so that's why I'm modifying it, and I'm also going to be modifying the drive file, some of the functionality of the drive file. This model in particular is just running right up on this wall all the time. This is not like a new thing. This is happening all the time. I increased the speed in the model too, so it's going a lot faster. And let's see if it can find its way back on it. No, it's up. Yeah, it's in the water. All right, so let's see if we can. Oh, whoa, it's still going though. All right, let's see if we can make this thing better. All right, the next part of this project is to take this drive file that I referenced. This is the file that I executed in order to control the vehicle automatically. And this file is kind of old. It's a few years old, and I just need to reconcile some of the differences between the environment of my model and this drive file. The drive file that I have here is using a Keras model, and I'm hoping that it won't be too much of an issue to use PyTorch. So I just need to go into this code a little bit and figure out where, just replace their model with my model. It's going to be worse, but I just need to do it before we actually start training the model, and I just want to make sure that everything's going to work properly. So once I get this working, then I'm going to start actually training the model. All right, I think I got this thing working. So it looks like the output, it's just named steering angle right now because that's what it was originally. So steering angle is returning my two, or I don't know how many dimensions that is, but it has two values, two outputs from the model. And I don't even remember the order that they're in. I just wanted to make sure that I could get some data from this thing. So we are in business now. I got everything. I have the full thing set up, good to go. Now I want to go through this code, clean it up a bunch, and then we are going to train this model. We are going to just collect a ton of data. I'm going to create a nice pipeline. Then I'm just going to collect data, and right after I collect it, I'm going to run my pipeline. It's going to do the pre-processing. It's going to train the model, and then I'm going to test the model, and that is going to be my cycle. I'm going to create this rapid iteration cycle to build a model that actually works. So that's it. We're in business. Let's just try this thing out. Let it run. See how it does. So this model has not been trained yet. but let's just see how it does. I would imagine it's pretty much just gonna drive straight. Oh, some turning going on. All right, there we go. Nah, it's just going straight. It's just from running into the wall as it was turning a little bit. All right, well, let's see if we can make this thing better. We are in business. We have a good potential flow that we can create now. I'm going to fix up this code and I'm gonna train this model.